Every country aiming for the top is hungrily eyeing the US, China, Russia, and North Korea. None are left out. But the US has something they all don't: an advanced sixth-generation fighter the world has never seen. This $300+ million fighter would end any war targeted at the US before the war even has a chance to begin. Packed with an avionics suite that lets it spot targets on the other side of the planet, an armament suite that enables it to strike those same targets, and a stealth suite that allows it to hide in plain sight. This new fighter is an aerospace revolution the world is probably not prepared for. Aerospace Revolution. The Next Generation Air Dominance, or NAD for short, is the program developing the fighter that will ensure the next generation of American air dominance, just as the F-22 Raptor has done so excellently for decades. The new NAD fighter will be sleek, aerodynamic, and feature an elongated, blended fuselage that completely shatters the laws of physics. Within this fuselage will be three war-defining technological wonders: an AESA radar, stealth, and adaptive cycle engines. The NAD program is also developing new, Advanced Active Electronically Scanned Array, AESA radars that would power the fighter, giving it a sense-all, kill-all advantage. Active Electronically Scanned Arrays, or ACE radars, have many advantages over the previous generation. They eliminate the need for mechanically scanning rapidly in different directions, doing away with the clunky moving parts of their predecessors. This makes them more reliable and, in some cases, more compact and lighter. These radars can scan massive volumes of airspace and large areas of the planet's surface extremely quickly, while keeping track of multiple targets with peak reliability. They complement these capabilities with high sensing resolutions, immunity from electronic warfare attacks, enhanced performance against stealthy targets, and being stealthy themselves. For even better performance, the NAD fighter will do away with traditional radar mounts in favor of futuristic, electronically configured smart skins integrated into the aircraft's fuselage. This allows the AESA radar to offer a level of sensor fusion never seen before by fusing the functions of sensors, electronic warfare systems, and communication systems into a single multi-mode AESA array. Instead of multiple systems each doing one thing, AESA radars now do it all: super-fast scanning, spherical coverage, very high-power electronic warfare data, identification friend or foe, precise narrow beam abilities, and wideband capabilities. The data from all these individual functions are combined to form a detailed, seamless, tactical, godlike picture of the battle space. Using these self-sufficient AESA radars would make the aircraft system easier to upgrade, both in terms of software and hardware. Testing and validating the multiple functions could also be drastically accelerated under the NAD program. NAD is touted by the Air Force as a program that will birth an entire family of systems, including the manned sixth-generation fighter, radars, unmanned fighters, and more. If the manned and unmanned fighters host the same AESA radar family, it would allow for far more seamless integration and massive economies of scale. It could also simplify maintenance, as the commonality of replacement units and parts would allow for more efficient operations. The fewer system types to maintain, the more consolidated critical tasks become. Updating core software would also be more of a do one, get one done situation. It's important to note that this level of sensor fusion is still a fragile concept that requires gifted hands and brains to pull off. But, with the benefits it offers and the incredible American talent working on the NAD program, it's only a matter of time before it's achieved. Now, stealth. The technology that makes 20-ton flying vehicles virtually invisible in the sky. The NAD fighter will maximize stealth, which isn't a single technology added to a fighter, but rather a set of measures to ensure both the human eye of enemy soldiers and radar waves from enemy radars are unable to spot the NAD fighter as it flies silently above them. To be stealthy, the fighter must reduce its radar cross-section, infrared signatures, and acoustic signature. While the exact approach of the NAD fighter remains a closely guarded secret, we can make calculated assumptions. The radar cross-section is how much radar energy an object reflects back to the source. If the source receives a significant amount of radar energy, it knows an aircraft is in the air. To avoid detection, an aircraft must return minimal radar energy. In line with this, the NAD fighter will be shaped with smooth, angular surfaces that deflect radar waves away from the source rather than reflecting them back. It will also have no vertical stabilizers to minimize reflective surfaces. This will be the first fighter in history with such a design. The fighter will also be coated with radar-absorbent materials that absorb or scatter radar waves rather than reflecting them. To reduce the infrared signature, cooling systems inspired by the North Pole will be used to cool down the aircraft's engines and exhausts. Heat sinks, or exchangers, will also dissipate heat by transferring it to other parts of the aircraft or to the surrounding air. In addition to being cooled, the engines and exhausts will be shielded from the direct view of infrared sensors. Finally, the acoustic signature must be reduced. Acoustic signature refers to how much noise an object creates. The NAD fighter must operate in complete silence. One engine hiccup or noise could make the difference between a successful mission and an encounter with a surface-to-air missile. To keep the acoustic signature low, the NAD fighter must have engines, propellers, or fans specifically designed for noise cancellation, noise masking, and other noise reduction technologies. All of these features will combine to make the fighter undetectable, allowing it to access anti-access areas undetected, perform its mission, and leave without a trace. Now, the engine. The engine powering the NAD fighter is currently being developed through the ENGGAP program, Next Generation Adaptive Propulsion. This massive sub-program is on the hunt for a revolutionary jet engine. Nearly $3 billion in contracts have already been awarded to Pratt & Whitney, General Electric, Boeing, Lockheed Martin, and Northrop Grumman. While the latter three don't traditionally build engines, they are the most likely manufacturers of the NAD fighter. By awarding them engine contracts, the NAD program could result in a groundbreaking airframe engine integration. The new ENGGAP engine will reportedly be an adaptive cycle engine, allowing the fighter to toggle between more speed and more range at will. A level of versatility the world has never seen before. Adaptive cycle engines are designed to operate efficiently under subsonic, transonic, and supersonic speeds, making them suitable for next-generation military aircraft and supersonic transport. They can switch between high thrust and high efficiency, allowing the fighter to adapt to different flight conditions. Adaptive cycle engines are built using a three-stream architecture, where an additional bypass stream increases the bypass ratio when fuel efficiency is required, or air is directed to the core for greater power when necessary. The engines built under ENGGAP will follow this concept, and when they enter service, they will be America's biggest jet engine upgrade of the century. With new AESA radar systems, tailored stealth designs, adaptive cycle engines, and an arsenal of kinetic and laser-directed energy weapons, the NAD fighter will be stealthy, agile, intelligent, and lethal. It will be an undetectable and unstoppable force. The Air Force's air dominance plan for the future revolves around 200 NAD fighters operating alongside 300 F-35 Lightning IIs. The combined 505th and 6th generation fighters will each be assigned 2 unmanned loyal wingmen as escorts. Over $4.2 billion has already been spent on the NAD program, with an additional $11.7 billion expected between fiscal years 2024 and 2027. An additional $40 billion will also be spent on the program. The NAD fighter will begin entering service around the 2030s, replacing the F-22 Raptor as the top air superiority fighter. The sixth generation of fighter jets is finally here, and they promise to be the most intriguing, most unconventional, and most jaw-dropping pieces of military technology the skies have seen in a long time. To follow the progress of this incredible journey, be sure to subscribe to this channel and give this video a like. Thanks for watching.